In this video, we'll look at one of the most common and important operations involving data frames, merging them together. To do this in Pandas, the workhorse function is merge. To motivate it, suppose we're doing some analysis for a veterinary office, and the office has two tables of data: pets, which has one row per pet, here the index represents each pet ID, and visits, which has one row per visit, where the index represents each visit ID. The merge function has four types of joins: left, right, outer, and inner, with the default being inner. The join type determines which keys show up in the result. Let's start with inner join. The result of an inner join only includes keys that exist in both the left and right tables, although a single key can appear multiple times in the result if it appears multiple times in one of the input tables. This makes more sense when you see it, so let's look at an inner join between pets and visits based on pet IDs. Here we call pd.merge and we designate pets as the left table, visits as the right table, the join type as inner, left index equals true because in the left table, i.e. the pets table, pet IDs are stored in the row index, and right on equals pet ID because in the right table, i.e. the visits table, pet IDs are stored in a column called pet ID. In other words, we want to join the row index in the left table to the pet ID column in the right table. Notice a couple things about the result. Pet ID 11 is excluded because it only existed in the pets table, and pet ID 31 is excluded because it only existed in the visits table. Also, pet ID 42 occurs 6 times in the result because it occurred 3 times in the visits table, each of which matched to 2 occurrences in the pets table. When your DataFrames row index has some specific meaning, kind of like ours, it's a good practice to give it a name. So let's go ahead and rename the row index in pets to pet ID. And let's rename the row index in visits to visit ID. A convenient benefit to naming the pet ID index is that we can rebuild the inner join from before using on equals pet ID instead of setting left index equals true and right on equals pet ID. When you use the on keyword like this, Pandas searches both tables for matching column name and or row index to merge the tables with. Also notice that this result is slightly different than our previous version, specifically the resulting row index is different and the resulting column order is different. I'll touch on that a bit later. Now let's look at a left join. The result of a left join retains all and only the keys in the left table. Let's see it in action, again making pets the left table and visits the right table, and joining on pet ID. In this case, the left table, pets, includes pet ID 11, which doesn't have a matching record in the right table, visits, but the result still includes it. And for unmatched records like this one, Pandas fills in the columns from the right table with nan. Also note that pet ID 42 again expands into 6 resultant records. Next up is right join, which is exactly the same thing as a left join, just reversed. So if we do pd.merge left equals pets, right equals visits, how equals right, on equals pet ID, in this case pet ID 11 is excluded, but pet ID 31 is retained in the result. The last type of join is an outer join, which includes every key from both tables in the output. Somewhat disappointing is the fact that Pandas doesn't have a native anti-join, which basically answers the question, what records from table A don't match any records from table B? But there's a couple ways we can cook this up. Suppose we want to see what records in the pets table don't have a matching record in the visits table via pet ID. We can start by doing an outer join with indicator equals true. That'll produce an output like this, where the column _merge indicates if the resulting record came from the left table, the right table, or both. From there, it's pretty obvious how to get the records in pets, not in visits. Just filter the result where _merge is left only. The nice thing about this is that it's simple. The downside is that it's extremely memory inefficient. We're unnecessarily creating this big intermediate table before we filter down to the one row that we care about. So the second method for implementing an anti-join is a little trickier, but it's more memory efficient. The basic idea is, for each pet ID in the pets table, we check if it exists in the visits table using the isIn method. Then we negate the result and use that to subset the pets table. So if we do pets.index.isIn, open parens visits.petid, we get back a Boolean array indicating whether each pet ID in the pets table also exists in the visits table. Then we can negate that array and use it as a Boolean index to subset the pets table. Since the visits table includes duplicate pet IDs, we can slightly improve this by using only its unique pet IDs. Before I close out this lecture, I want to briefly mention a few things. First off, if you want to join data frames using multiple columns, you can do that too just by passing in a list of column names. Secondly, if you join two tables A and B using A's index and a column from B, the resulting data frame will inherit its index from B. If you join on columns from both tables, the resulting data frame will create a brand new row index. Lastly, let's say you left join table B onto table A, meaning A is the left table and B is the right table. The rows in the result will be ordered by first when they occurred in A, and second when they occurred in B. Here's an example that shows what I'm talking about. You can see how the rows in A never swap positions, nor do the rows in B with the same key. The kicker is that this behavior isn't documented, so while it can be useful in some situations, you might not want to rely on it. I asked about this on GitHub, and kind of frustratingly, no one got back to me. Also, this behavior doesn't work for right joins, which some people have already classified as a bug, and is supposed to be fixed soon, hopefully by the time you're watching this video.